everybody, in this video we're going to talk about part 2 of sum of the first n terms of a geometric sequence. And in this video we are going to take a look at this notation. This notation is called summation notation, or the symbol is called a sigma. I have previous videos about talking about these symbols here. But what this means is I'm going to start my j at 1, and then I'm going to increase it by 1 until I get to 12. So I have 2 to the 1, 2 to the j, or 2 to the 1, and then I'm going to increase that j and go 2 squared. Then I'm going to increase that and go 2 cubed, and then I'm going to keep going until I get to 2 to the, not 12. 12, 2 to the 12th power. But then this sigma right here, that little symbol right there, well, it's a big symbol, right? Means that we are going to add in between each of these. So here we can see we have the sum of the numbers 2 squared, 2 cubed, all the way up to 2 to the 12th power. I can rewrite these as 2 plus 2 times 2 to the 1 power plus 2 times 2 squared plus 2 times 2 to the 11th power. And as you're thinking about that, you think, wait, why did you do that? Well, this, if you watch the other video, looks more like the other sums that we're used to seeing. Now, what is the equation that we're going to use? The sum of the first n terms in a geometric sequence is a sub 1 times 1 minus r to the n over 1 minus r. Remember, my r is what I'm multiplying by each time. So my r equals 2. A1, or a sub 1, is equal to my first term, which I found by plugging in the j. It is also 2 in this case. Okay, now n. n is how many terms I'm dealing with. From 1 to 12, how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is equal to 12. Remember in my previous video, I also can look at this last exponent, and that is equal to n minus 1. If I've factored out my a1 first, okay, which I did. So that's another way we can get 12 for n. So the sum of the first n terms, or the first 12 terms, is equal to a1, which is 2, times 1 minus r, or 2 to the nth power, the 12th power, over 1 minus 2. After some simplifying, we get 2 times negative 4,095 divided by negative 1. So this sum of the first 12 terms is 8,190. There's one example. Let's do another one. Here's my next one. I have this sum of j equals 1 to 8 of 1/4 to the j power. So my first term, a1, is going to equal whatever the value I get out for my first term, which is 1/4 to the 1 power. So that's the first j that I put in. So my a1 is equal to 1/4. My r is equal to the value that I'm raising to the power, which is 1/4. Now, how can I get that out? Well, my sum is going to be 1/4 plus 1/4 squared plus 1/4 cubed. So I can see, what am I multiplying by? I'm going to be multiplying by 1/4 every time. So that is my common ratio. right there. And my final term is going to be 1/4 to the 8th. So now my terms, how many terms do I have? I start at 1 and I go to 8. So I have 8 terms. So the sum of the first 8 terms of this sequence is equal to the first term, or 1/4, times 1 minus r to the n power divided by 1 minus r. Well, I didn't do a very good job on that parenthesis, but it needs to be multiplied by that whole fraction. So after some simplifying, I'll get 1/4 times 1 minus, let's go back a little, I need to leave myself some room. 1 minus 1 over, so 1 to the 8th over 4 to the 8th is 1 over 65,536. And then in this denominator, the bigger denominator, I have 3/4. So let's continue to simplify. This in the numerator is going to end up being 65,535. And then in the denominator, because I'm going to multiply this 1/4 through. You know, let's actually, I'm going to do it a little bit of a different way. Let's go back a minute. Sometimes you see a little bit of an easier route, and that's what I began to see. So this is 1/4 times 65,535 over 65,536, and that's just the numerator. Now then I'm dividing that big numerator by 3/4. Now I gotta multiply my fraction straight across, so 1 multiplied by this entire fraction, and then 4 multiplied by the denominator is going to be 65,535 over 65,536. And then what is 4 times 3/4? Well, the 4's make a 1, so it's just 3 in the denominator. Now, after some further simplifying, we will get 21,845 divided by 65,536. And that is the total sum of the first 8 terms in the sequence.